In this video, I will show you how to use Biot-Savart's law for a single charge to find the direction of the magnetic field. And that is not straightforward. When we were finding electric fields from charges, it was much easier. We knew that the electric field from a positive charge was pointing away from the charge, and the electric field from a negative charge simply points towards. Things are much more complicated in magnetism. So the magnetic field that charge 1 creates at the location of charge 2 depends on the sign of charge 1, and it depends on the velocity of that charge, and it also depends on the vector, the relative position vector of the observation location with respect to the source. I'm going to show you how you will be using this. Now, one thing that I do want to mention, I'm only interested in finding the direction of the magnetic field. Okay, I don't care about the magnitude, and this allows me to say, since this is a constant and the constant is always a positive number, it doesn't really affect the direction of the magnetic field. Essentially the distance between the observation location and the source location is also a positive number, and it does not affect the direction of the magnetic field. So the quantities that affect the direction of the magnetic field are really here. Okay? You can safely, as far as the direction is concerned of B, you can safely ignore these things. I'm going to focus on that because that's what really matters. Now, I have written here the steps that I will use to find the direction of B. I'm going to start by figuring out what's the direction of the velocity vector, what's the direction of the r hat vector, what's the direction of the cross product, and then what's the direction of B. I'm going to start, let's say I have a charge, let's make it a positive charge, and it is moving this way, and I want to find the direction of the magnetic field that it creates here. Now, this means that this is the source, and this point here, this is my observation location. Now, this, when you see B from 1 to 2, what I mean with that, this is the magnetic field that the charge at location 1 creates at location 2. This is the source, that's the observation. So this is source, and this here too is observation. Now, okay, I said that my charge is moving to the right. This is the charge that creates the magnetic field here. This is 1, okay? And V1 is the velocity of this charge. So I'm gonna use the same color to represent these vectors. So red for V1, red for V1. This is the velocity that I need to use here. First step. Find what's the direction of the velocity of your charge that creates the magnetic field. Step 2. Find the relative position vector of the one that goes from the source to the observation. From the source to the observation. So this is the unit vector that goes from the source to the observation. This is r hat. Okay, blue for r hat. Now, I need to find, step 3, I need to find the direction of the cross product. Okay, I found this, I found that. Now I'm going to find what's the direction of the cross product. To find the direction of the cross product, as I showed you before, I need to use the right hand rule. And the right hand rule says I need to place my fingers in the direction of the first vector, which is V1. So here it is. And then I need to move my fingers, to curl my fingers in the direction of the second vector. So if I'm here, I'm doing this, and then my thumb shows me the direction of the cross product, and here is my arrow. If I do towards V, towards R hat, then my thumb goes up, means that this here is the direction of the cross product. It's going out of the page. So with green, for this point over here, the cross product V1 cross R hat from 1 to 2, this goes out of the page. The dot with a circle around it, it means that the magnetic field here points this way, towards you. Now, the last step is to find the direction of B. And I'm gonna do that. Okay, let's summarize what I have so far. I know I found V1, I found this, I found the cross product. The last thing I need to do in order to find the direction of B is to take into account the charge Q1. If Q1 is a positive number, then this vector and this vector point in the same direction. If Q1 is a negative number, then that minus sign will essentially mean that B points in the opposite direction of the cross product. Now, the charge that I have here is a positive charge. So, whatever direction I found for the cross product, B will point in the same direction. So, since the cross product V cross R hat points out of the page, the magnetic field here also points out of the page. So for B, that's my observation location. The magnetic field here points out of the page. B from 1 to 2. Now, I'm gonna do one more example. And now I'm gonna use a negative charge just to show you the difference. So let's say I got a charge here, a negative charge. And I'm gonna say that this one has velocity to the left. So this is V1. Now let's say that I want to find, okay, first of all, let's mark it. This is the source. Let's say I want to find the direction of the magnetic field here. This will be my observation location. Now I found V1, the red arrow. Now second step, I need to find the direction of the unit vector R hat that goes from 1 to 2, from the source to the observation, from the source to the observation. So R hat will be this one. And now I need to use the right hand rule to find the direction of the cross product. Towards the first the fingers of the right hand towards the first vector, curl them, move them in the direction of the second one, and my thumb will show us where this is going. So towards the first vector V, curl them towards the second vector R hat, and my thumb goes again out of the page, which means the cross product, the direction of the cross product here at the observation location goes up again out of the page. So V1 cross R hat from 1 to 2 goes out of the page. Now, I said the last step is to find the direction of B, and B depends on what is the sign of the charge that is creating the magnetic field. Since here now I have a negative charge, since the cross product goes out of the page, the negative number here will make B to be pointing in the opposite direction of the cross product, and the opposite of out of the page is into the page. So the magnetic field goes into the page at the observation location. This is B, that the source chart creates at this location. It goes into the page.